Alright folks, this video is about electricity. First off, what is electricity? When negative charges or electrons move through a wire, then there's electricity. We carry electricity through wires, then we usually convert that electrical energy into some other type of energy. For example, you might plug in a power drill to an electrical circuit and it runs a motor, which would turn into mechanical energy. Or it could be a toaster, which would be thermal energy. There are two types of electrical circuits. For electricity to flow, there must be a complete circuit. If the circuit's broken, then the electrons cannot move through that wire because they can't jump over a gap. So the two types are series and parallel. In a series circuit, everything's all just in a circle with itself. It's all in a row. So we have a battery, the electrons flow, they go in through a light bulb and then back out the light bulb, then into another one, then back out, then into another one and back out, and then it returns to the battery. Notice there's no gaps in that whole circuit, so the light bulbs are lit up. The problem with series circuits is that if one of these light bulbs goes out, the whole circuit won't work because there's a gap. Parallel circuits, on the other hand, they incorporate branches. So when you have the electricity flowing out of the battery here, there's a branch point. It could either go straight or it could turn. So when one of these light bulbs goes out, the electricity stops flowing for that particular branch, but it still has another path to go through. So it can continue flowing for the rest of the circuit. When we draw circuits, there are various symbols that we're going to use. Just a simple line represents a wire. A line with some zigzags in it is a resistor. A light bulb is usually a circle with an X through it, and you would put that somewhere on the wire. Or if you really wanted to, you could draw a little light bulb with a little filament in it, just for fun. A battery is a very long line and a short gap, and then a little short line. That represents a battery. And a switch would look like this, because you can move this line. If you put it down, that would complete the gap in the circuit, and then electricity would flow. Or you could move it up, flip the switch, and then it would turn it off. To describe an electrical circuit, there are three things we talk about: is current, voltage, and resistance. The electrical current is the rate of electrical flow. So how fast are those electrons moving through the wire? We measure that in amperes, or A for short, a capital A. It's analogous to how fast water is coming out of a hose. So we could measure how many gallons per minute come out of the end of a hose, and that would be similar to our electric current. It's how many electrons are flowing per unit of time through our wires. Voltage is a pressure source for electricity. You have to have this pressure in order to push the electrons through. Now, if you don't have a voltage, then there's no current. We measure it in volts, or a big capital V. And it's similar to the pressure difference causing water to flow through a hose, like when you siphon something. So you could stick a hose in maybe a pool and get the water flowing through it. And then once you put the hose down on the ground, it has a much lower pressure on the ground than it does at the pool. So it moves from the high pressure at the top, a larger height, to the lower pressure and continues to flow. So you need that pressure difference in order for a current to happen. And then resistance is what slows current down, and it can be affected by the type of what type of metal you're using for the wire, or what type of material in general. For example, a copper wire conducts electricity very well. It doesn't have a lot of resistance, but if you made a rubber wire, there's a lot of electrical resistance there, and you probably wouldn't have any electricity flow through it. Also, the longer the wire, the more resistance there is, and the bigger the wire, the diameter, the less resistance there is because there's more room for those electrons to flow through. We measure resistance in ohms, named after the guy who came up with it, and we use the Greek letter omega for that. It's similar to if you have a larger diameter hose, then it's going to be easier for water to flow through. Or if you have a shorter hose, it doesn't take as long for the water to get from one end of the hose to the other. So here comes the math. Ohm's law basically just says that if there's more resistance, there's less current, or if there's more voltage, then there's more current. And here are the equations you would use. V equals, the voltage equals the current times the resistance is the major equation. And then you can use all the different forms of that there. It's also handy if you remember this little triangle because you just, whichever one you're looking for, say you're looking for voltage, you cover that up, and then you know that it's I times R. Or if you're looking for resistance, you know it's V divided by I.